They were hailed as evidence of water on the red planet, but strange streaks on the red planet's surface could actually be sand, a NASA study has found. The find was originally hailed as a major scientific discovery in 2011 as results seemed to confirm that dark fingers spotted in Mars Reconnaissance Orbiter (MRO) images were likely made by liquid moving across or beneath the planet's surface. However, now NASA believes they could be granular flows, where grains of sand and dust slip downhill to make dark streaks, rather than the ground being darkened by seeping water. In 2011, Lujendra Ojha accidentally discovered finger-style marks on Mars after studying images of the planet's surface taken by the Reconnaissance Orbiter in 2011. Not only did the markings appear to move, they did so in a pattern that would be consistent with flowing water. It was proposed these changes were caused by a volatile substance, but the environment is too warm for carbon dioxide frost, and too cold for pure water. Instead, it was suggested that a kind of brine was on or beneath the surface, and until now this had not been proved. Since his discovery, observations of similar sites on Mars have revealed that the finger-like patterns seem to emerge in warmer seasons and die away during cooler seasons. Researchers carried out a new analysis of the streaks with a powerful camera on NASA's Mars Reconnaissance Orbiter (MRO), shows they exist only on slopes steep enough for dry grains to descend the way they do on faces of active dunes. The findings published today in Nature Geoscience argue against the presence of enough liquid water for microbial life to thrive at these sites. Many thousands of these Martian features, collectively called recurring slope lineae or RSL, have been identified in more than 50 rocky slope areas, from the equator to about halfway to the poles. We've thought of RSL as possible liquid water flows, but the slopes are more like what we expect for dry sand, said Colin Dundas of the U.S.Geological Survey's Astrogeology Science Center in Flagstaff, Arizona. This new understanding of RSL supports other evidence that shows that Mars today is very dry. However, exactly how these numerous flows begin and gradually grow has still not yet been explained. Authors of the report say it could include small amounts of water, indicated by detection of hydrated salts observed at some of the flow sites. These features have evoked fascination and controversy since their 2011 discovery, as possible markers for unexpected liquid water or brine on an otherwise dry planet, said NASA. They are dark streaks that extend gradually downhill in warm seasons, then fade away in winter and reappear the next year. On Earth, only seeping water is known to have these behaviors, but how they form in the dry Martian environment remains unclear. Dundas is lead author of the report, which is based on observations with the high-resolution imaging science experiment, HiRISE, camera on MRO. The data include 3D models of slope steepness using pairs of images for stereo information. The RSL don't flow onto shallower slopes, and the lengths of these are so closely correlated with the dynamic angle of repose, it can't be a coincidence, said HiRISE principal investigator Alfred McEwen at the University of Arizona, Tucson, a co-author of the new report. The seasonal dark streaks have been thought of as possible evidence for biologically significant liquid water, sufficient water for microbial life, though explaining how so much liquid water could exist on the surface in Mars' modern environment would be challenging. A granular flow explanation for RSL fits with the earlier understanding that the surface of modern Mars, exposed to a cold, thin atmosphere, lacks flowing water. A 2016 report also cast doubt on possible sources of underground water at RSL sites. Liquid water on today's Mars may be limited to traces of dissolved moisture from the atmosphere and thin films, which are challenging environments for life as we know it. Seasonal changes in hydration of salt-containing grains might result in some trigger mechanism for RSL grain flows, such as expansion, contraction, or release of some water. Darkening and fading might result from changes in hydration. If atmospheric water vapor is a trigger, then the question is why the RSL appear on some slopes but not others. RSL probably formed by some mechanism that is unique to the environment of Mars, McEwen said, so they represent an opportunity to learn about how Mars behaves, which is important for future surface exploration.